All right, so we are back in, this is section 5, but it's part 2, because these are distance, rate, time problems. And so in the past, you have learned that distance is equal to rate times time, or D equals R times T, okay? And so there's different ways that people can travel. So the first one that we're going to look at is same distance travel. So it means that people are going the same distance. The next one we're going to look at is round trip travel. So if somebody goes to work and then goes back home, or you take a trip to New York and then you come back home from New York. And then another one is opposite direction travel, which means that they might start in the same place, but they're going to travel in opposite directions. So there's 3 types of distance, rate, time problems. And I'm going to tell you that creating a table, we're going to look at one in just a second, is the easiest way to solve these problems. It's kind of the easiest way to set up your information, to get the information down, and to make sure that you're doing it correctly. So this one says, a group of campers and one group leader left a campsite in a canoe. They traveled at an average rate of 10 kilometers per hour. 2 hours later, the other group leader left the campsite in a motorboat. He traveled at an average rate of 22 kilometers per hour. How long after the canoe left the campsite did the motorboat catch up with it? And then how long did the motorboat travel? So there's 2 questions that it's asking us to answer. If you notice, I have a table set up here and it says rate, time, and distance. So don't forget, rate times time is equal to distance. So we have 2 groups basically. We have a group that left in a canoe. So I'm going to fill that in right here. And then you had your other leader who left in a motorboat. Okay. Now, if you look back up here, let's look at some information that we have. It says that the canoe traveled at a rate of 10 kilometers per hour, and the motorboat had an average rate of 22 kilometers per hour. So let's go down here and fill that information into the table. So the canoe was traveling at 10 kilometers per hour, and the motorboat was traveling at 22 kilometers per hour. Okay, so I got that information out of the top part. The next piece of information that it actually gives us is about the time. Okay, you had the canoe leave, and then it says 2 hours later the motorboat left. And so we have to take this information and figure out time. And this time here is representing the time traveling. Oops, I just spelled traveling wrong. So the time traveling. So there's a couple ways that you can do this. Let's say the canoe left. So the canoe's been traveling for T hours. Well, if the canoe's been traveling for T hours, the motorboat would have been traveling for T minus 2 hours. And the reason why that is because if the canoe left and it was traveling for 4 hours, okay, well, the motorboat only would have been traveling for 2 hours because it left 2 hours later. Okay, so now the distance. We don't know the distance, but we do know the distance is rate times time. So what I can do is take this information right here, this rate and this time, to come up with my distance. And so rate times time here would be 10 times t, or just 10t. And then the motorboat, get my highlighter back, is 22 times this t minus 2. And so in this case, it's 22 times t minus 2. And it has to be in parentheses because it's the rate times the total time. Okay? So as we mentioned before, this is a same distance traveled problem because basically if you were to picture this, here's my canoe and my canoe took off. Okay, and the distance for the canoe is 10t. Now we have the motorboat. Well, the motorboat left 2 hours after, but it's asking how long before the motorboat caught up. So they're still going the same distance. And remember, the motorboat's distance is t minus 2, 22 times t minus 2. And so what we can do here is we can actually set these two distances equal to one another because it's the same distance. So 10t is equal to 22 times t minus 2. Okay, so I know this kind of seems confusing, but kind of just hang with me for a second. We're going to solve this equation. 10t is equal to, well, we got to use the distributive property over here, 22t minus 44. And let's just keep going. Let's keep solving this. We have variables on both sides, so I need to get my variables to one side. So I'm going to subtract 22t. That crosses out. Over here I have negative 12t is equal to negative 44. Okay. So then what I'm going to do is divide by negative 12, divide by negative 12. So t is going to equal, let's see, let me get my calculator out. 44 divided by, it's going to be 3 2/3 hours. So what that means is the canoe, because remember, let me get my other highlighter, let's get another color. Remember your, whoops, guess it didn't like that. Remember the canoe was traveling at t, so here's t. The canoe traveled 3 2/3 hours. All right? So the first question right here was how long after the canoe left the campsite did the motorboat catch up with it? Well, the answer to that question would be 3 2/3 hours later. And so the second piece says, how long did the motorboat travel? Remember, the time for the motorboat is this t minus 2 right here, so it's 3 2/3 minus 2. So that answer would be 1 2/3 hours. Okay, so we took these distances and we set them equal to one another because they were traveling the same distance. So let's look at another one. This is an example of a round trip travel. So that means that somebody left for work and then came home. So it says on his way to work from home, your uncle averaged only 20 miles per hour. On his drive home, he averaged 40 miles per hour. If the total travel time was 1.5 hours, how long did it take him to drive to work? So think about that. There's home, and there's work. So home, work. Basically, on his way there, okay, he went 20 miles per hour, okay, and then on the way home, he went 40 miles per hour. And then the other information that we know here is if the total travel time was 1.5 hours, so the total time for both trips was 1.5 hours. So let's see how we can organize this in our table. So basically we have two things, to work, okay, and then from work, so going back home. To work and then to home or from work. Remember the rate to work was 20 miles per hour, and the rate on the way back home was 40 miles per hour. Now we have to take this information that it gave us right here, this total time of 1.5 hours. Well, if I said it took t hours to get to work, okay, to get home from work would have to be this total, this 1.5 hours, minus the time it took me to go to work. So you have to take that total time and subtract it from the time it took him to go to work. Again, remember distance is rate times time is equal to distance, so that's how we're going to get our distance here. This ends up being 20t, and down here it's going to be 40 times 1.5 minus t. And in this case, is the distance the same again? The answer to that question is yes, because it's going from home to work and work to home. So the distances are the same. So what I'm going to do here is take this 20t and set it equal to this 40 times 1.5 minus t. We're going to start by doing the same thing. We need to distribute over here. So we have 20t is equal to 40 times 1.5 is 60 minus this 40t. Now if you notice, I have variables on both sides of my equal sign again. And so what I'm going to do is I'm going to move this 40t over to the other side with the 20, so plus 40t. That crosses out. I have 60t is equal to 60. I'm going to divide by 60 to solve for t. So t is equal to 1. What that tells me, I'm going to go back up to my table now. If I can get my highlighter here. There's my t. So what that tells me is it took him 1 hour to work. All right. And so when I go back up here and look at the question that it asked me, it did ask me how long did it take him to drive to work. So the answer to that question would be 1 hour to go to work. If it took him 1 hour to go to work, just kind of curious here, how long did it take him to get back home? And so remember the total travel time. Remember the total travel time was 1.5. And so to get home it was 1 1/2 minus your t. And so it would have taken him a half hour to go home if it would have asked us that question. That's how we would have found that out. So last, it's opposite direction travel. What this one means is that basically they're leaving from one spot and somebody's traveling this way and somebody's traveling this way. They're going in opposite directions. So the problem says, Sarah and John leave Perryville traveling in opposite directions on a straight road. Sarah drives 12 miles per hour faster than John. After 2 hours, they are 176 miles apart. Find Sarah's speed and John's speed. So the two people we have here are Sarah and John. Okay, if I look in this information here, it tells me Sarah drives 12 miles per hour faster than John. Okay, so let's say John is R, while Sarah is driving 12 miles per hour faster than John. So it would be R plus 12. Now let's just say if I started by giving Sarah R, that's okay too. If I gave Sarah R, John would have to be R minus 12 because he's driving slower. But I didn't do it that way. But if you would have done it that way, you would have gotten the same answer. Okay? Now this one's a little bit different because in the problem it tells us after 2 hours. And so the time here is actually just 2 hours because they're both traveling for 2 hours. Now remember, distance is equal to rate times time. So I'm going to take this time, this 2, times my rate here, R plus 12, and then this one would just be 2R. Now I know some of you are thinking to yourself, but wait a second. It told us here, hold on, they're 176 miles apart. It tells us the distance. Well, that tells us the total distance. It does not tell us Sarah's distance and John's distance. Okay, so think about this for a second. Let's say this is Sarah and this is John. Sarah's distance is 2 times R plus 12, and John's distance is 2R. The total distance is 176 miles apart. So in this case, we're not going to set the two distances equal to one another because they're traveling different distances, but we know that their distances together is equal to 176. So what I did here, I took Sarah's distance plus John's distance, and that's equal to the total distance that they gave me. So now I have a multi-step equation. They don't even have variables on both sides. So I'm going to start by distributing 2R plus 24 plus 2R is equal to 176. I have some like terms on this side. 2r plus 2r is 4r plus 24 equals 176 minus 24. 4r is equal to 152. Divide by 4. R is equal to, what's that going to be? 38, I believe. Yeah, 38. So R is equal to 38. So again, we need to figure out what does that mean. If I go back up here, my R is right here. So what that R means is John's speed, John's rate. So John was going 38 miles per hour. Okay, so Sarah, how about I spell her name right? No, my eraser's not working. Well, you guys get the point here. So Sarah is R plus 12. So it's 38 plus 12 to get 50 miles per hour. So I think that for you guys, the best way to do this is to get some practice with these and to try some on your own, because you are going to have questions. A lot of people have trouble at first setting up their table and filling in their table, and that is normal. So if you're getting frustrated, just try to keep kind of picking apart the problem, figure out what information they're giving you, and then use these as examples. And then there's also more examples in your book that are a little bit different. So take a look at those as well. Good luck.